All right, so here we go, folks. Part two of the practice of midterm, or the practice problems, review problems for the midterm for my stats class. So midterm number 3, that is. So this is number 3. Notice here, for those of you that are in my class that notice the problem here has changed to 20 X-ray admissions, and that's because I originally had 31. And I did mention that if n was greater than 30, we can use a large sample size test for means. And so I wanted to make sure I gave you a small sample size test for means so you can see that and we can discuss that, because that's what's going to be on the test. So the other thing that I'm going to let you know is that on the exam, I will give you data, and I will give you an output of all of the necessary statistics for those data, as well as a histogram for the third condition, so you can deal with the third condition. You can have all the statistics, X bar, S, all that stuff, because I don't want you really to waste time trying to calculate all the statistics. Really, I just want you to get through the hypothesis test, okay? So let's go and write the 95% confidence interval for this one sample T. We're using a T procedure, a T test, a T distribution, because we have a small sample size. We have 20 is our sample size here. Our X bar is 62.3 and our S is 14. Now some of you are asking, well, how do I know that those are X bar and S and not the first, the 60 and the 12? It's because this is what the government says it should be, but the sample gave us these two numbers. And remember that X bar and SX are our sample mean and our sample standard deviation, okay? So now we're going to do our 95% confidence interval. Now our 95% confidence interval looks a lot like the one I just did, except we are using T instead of Z. So the first thing we need to do is we need to have a degrees of freedom. Degrees of freedom is n minus 1. So in this case, it's 20 minus 1, which is 19 degrees of freedom. So my confidence interval is X bar plus or minus T with 19 degrees of freedom. T star S over root n. So let's go and plug in what we know. X bar is 62.3 plus or minus, and I'm going to find T star in just a second, 14 over root 20. All right, so we got to find T star for 19 degrees of freedom. We're going to do that using a T table. So I'm going to show you my T table right here. And let's see, we want 95% confidence with 19 degrees of freedom. So we're going to go ahead and go to 95% confidence, which is down here. Okay. Oops, sorry about that, guys. 95% confidence, which is right here. And we're going to go all the way up to 19 degrees of freedom. Okay, so on the side there's 19 degrees of freedom, so we're going to follow that this way, follow this up, and we're going to get 2.093 as our T star. So we'll go ahead and go back here, and we have 2.903. Oh, still was using the same color from last time. Word is not the best thing to write this in, but I wanted to give you a copy. 2.903, let me make sure I was right on that. 2.093, whew. Tell you guys, it's late. 2.093. 2.0, oh goodness. Oh, come on. Come on. I'm sure you're getting a kick out of that at home. 2.093. Okay, so then we're going to go ahead and put that in the calculator and calculate that out. And we're going to get 55.75 and 68.85. So now we want to interpret that. We always want to interpret it. So we're going to say we are 95% confident that the true mean X-ray emission is between 55.75 millirads and 68.85 millirads. Millirads. It's radical. It's a millirad. Okay, so now we're going to do our hypothesis test here to see if the population mean is too high. Too high meaning it's too high if it's over 60, right? Because that's what the government says it should be. So my null hypothesis is going to be that mu X-ray, I'll just put X-ray, is going to be equal to, what do we say, 60, right? 60 is what we want it to be. Our alternative is that mu X-ray is going to be greater than 60. It's too high. Millirads. Okay, too high. We're going to use an alpha level of 0.05 once we get to the end here, okay? All right, so then we have our conditions and our conditions of inference. So we're going to write these down here. Remember that we have to have conditions when we have a hypothesis test. So our conditions. So this one's a little bit tricky here. Not really tricky. It's just that I didn't give you enough information to do this particular one, but there will be enough on the exam. So the first one is that, let's say the X-ray machines were randomly selected. Okay, so the first one has to do with randomness. The second one is that 20 is less than 10% of all X-ray machines. I know my handwriting gets to be like chicken scratch at night. And then 3, now 3 I have to show that the data that I have are unimodal symmetric, or that it comes from a population that's unimodal symmetric. Now I don't know that, but it did say a mean and standard deviation of that. But I'm going to go on the test, I will give you the histogram. So you're just going to make reference to that. So we're going to, in this case, we're going to assume, in this case right now, we're assume that the 20 X-ray machines, X-ray emissions is unimodal and symmetric. Okay, but you will be able to see that in the histogram on the test, okay? If you just have to make reference to it and tell me that it is, so that you can go and use the T model, okay? So then we're going to do our mechanics. Now our mechanics are just like our mechanics for the Z, except we're using a T with 19 degrees of freedom. And we're going to do 60, oh man, I can't remember what it was, 62.3, right, 62.3 minus 60 over the standard deviation over square root of n. So 14 over root 20. 14 over root 20. Okay, so we're going to go ahead and do that. We're going to get a t value of 0.735, and so we want to know if the p of t 19 degrees of freedom is greater than 0.735, and we did that greater than because it's what the alternative hypothesis was. Now I could find it in my calculator, but we'll use the T table because I know that a lot of people use the T table. And so what I'm doing is I'm looking for 0.735 in my T table. So 0.735, where's that going to be? With 19 degrees, come on, with 19 degrees of freedom. So 0.735 is going to be somewhere in here, right? So that's going to be somewhere in there, in between 0.2 and 0.25. So since our alpha level for this problem was right here, this is our alpha level for our problem. We know that the whatever that p-value is, or whatever that p-value is right here, it's going to be greater than 0.2, right? It's going to be on this side of 0.2. So I'm gonna write that down. Come on. It's going to be, this p-value is going to be greater than, it's going to be greater than 0.20, which is going to be greater than our alpha level, which was 0.05. Okay, so you can write that down. Now, if I actually calculated this this p-value, I'll tell you right now what I would get. I get a p-value of, the actual p-value is 0.236. Okay, so you see that it is greater than 0.20. And with the t table, that's all you can say. If you have a calculator, that can do this, then you would write 0.236. Anyway, we're going to go and write our conclusion based on that. Since the p-value is greater than our alpha level, there is no evidence that the mean emission is greater than 60 millirads. All right, so we're basically saying there's no evidence of the alternative hypothesis. Okay, so let me do one more here on this video, and then that's it for this one. Did I just do one problem? Jeez, I just did one problem. It's taking a long time because this machine is not working. Come on, move! I'm telling you guys, I'm sorry. This is Word is just, I should use the other one, the note one that I used before. Okay, so let me do another one here, and then we're going to go ahead and move on. If the p-value for a test is 0.032, give the conclusion. So all I want you to do is say reject or fail to reject the null based on an alpha level. Now, if the p is, notice here 0.03 is smaller than 0.1. So if the p is smaller, then we reject the null. The p here is still smaller, so we're going to reject the null. But the p here is larger, so we're going to fail to reject the null. All right, so this is simple. That's some easy points for you guys, all right? Okay, so I am going to go ahead and stop it here. I might have just echoed. Sorry, guys. And then in the last video, I'll go over 5, 6, and 7 very quickly. And that should be it. Okay. So I think that'll be it for tonight. And then I'll go ahead and record the last one tomorrow morning, and I'll post it up on Blackboard and YouTube tomorrow. Okay. So I'll catch you guys later. Bye.